computer science, then for class GS2, we're looking at the topic number system 1. So under number system 1, the specific objective that we're going to look at at the end of the lesson, the student should be able to define number system and list the digits in the number system, and we'll discuss the digits also. And at the same time, we'll be able to convert from one number system to another number system. So looking at number system, what is number system? This is a system. This number system is a way to represent or express numbers. In most cases, you would have heard of various types of number systems, such as the whole numbers and real numbers. But now in this context, because we are dealing with computers, we define other type of numbers system, which are the decimal number system, the binary number system, the octal number system, and the hexadecimal number system. So that's the basic one we are going to look at. But in the computing, the most important one is the binary number system, because the binary number system makes use of the machine language. When we talk of machine language in the computer system, the language that the computer understands consists of the binary number system. But we are going to look at each and every one of it one after the other. So the first one is the decimal number system. Now, this decimal number system is in base 10. The decimal number system is in base 10. So in this number system, the digits 0 to 9 represent the number, as it uses 10 digits to represent a number. So in the base 10 number system, we have 10 digits, and those 10 digits consist of numbers from x0 to 9. And it is also called the base 10 number system. That's why we have base 10 in the bracket here. So when you hear about the decimal number system, we are referring to the base 10 number system. And the base 10 number system consists of 10 digits, and those 10 digits range from 0 to 9, which represents the numbers in base 10. So the other one, which is the binary number system. The binary number system is in base 2. But the decimal number system is in base 10, while binary number system is in base 2. So a computer can understand only on and off, because it is an electrical component. So the only language the computer understands is only on and off. And that is the state of a switch. When we say the state of a switch, we are referring to an electrical switch now. Maybe at the house now you want to switch on your light. You notice your light you only have two-way, which is on and off. So this is the same type of technology that a computer uses in the communication. And these two states are represented by 1 and 0. These two states, which is on and off, are represented by 1 and 0. And the combination of 1 and 0 is what forms the binary number system. So in the binary number system, that means we only have two digits, and those two digits are 1 and 0. So, and in binary number system, we also call those digits base 2 numbers. So you notice that in these two ones that we have looked at, we have the base 10 numbers, which ranges from 0 to 9, but not up to 10, and the base 2 number that range from 0 to 1 also, which consists of only 1 and 0 digits. Now the third one we are going to look at is the octal number system. The octal number system is in base 8, and this system uses digits from 0 to 7, that is 8 digits. And the 8th digit represents a number, and the numbers are as base 8. Then the fourth one is the hexadecimal number system, which is in base 16. So in this system, 16 digits are used to represent a given number system, which means that it is also known as the base 16 number system. So each of these numbers have their bases, like the decimal is of base 10, the binary is of base 2, then the octal is of base 8, and at the same time we have the hexadecimal, which is of base 16. Now in this system, 16 digits are used to represent a given number. 16 digits are used to represent a given number in base 16. And this is also known as the hexadecimal number system. Now let's go and look at the number system chart. So Looking at this number system chart will give us a better understanding of what we are referring to. Now, under the table I've drawn here, we have the name of each number system, their base, and the symbols. That means their digits, the number of digits they have. Now, the first one is decimal. Decimal has 10 digits, and those 10 digits ranges from 0 to 9, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in base 10, we cannot get the number 10 there, because it only has 10 digits from 0 to 9. Then in base 2, we have binary. So binary is also referred to as base 2, which only has 2 digits also, which are 0 and 1. Then the octal is in base 8, and in octal it has 8 digits, which is 0 to 7, which are 0, 1, 2, 3, 4, 5, 6, and 7. Then the fourth one, which is hexadecimal. Hexadecimal is in base 16. Now, under base 16, the way the digits are also 16 digits, but there's a little bit different in the symbols. Here we have 0 to 9 here. So when it gets to 9, like we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. When it gets to 9, it starts with letter A to F, which is A, B, C, D, E, F. And each of these letters stands for some digits. For example, A stands for the 10 digits. This A stands for 10, then B, 11, C, 12, D, 13, then E, 14, and 15. So that's how the hexadecimal works. That's hexadecimal in base 16. Then octal is in base 8, which has 8 digits. Binary is in base 2, which has 2 digits. And decimal is in base 10, which has 10 digits. Then now, we're going to look at conversion from one conversion of number system. So under this conversion of number system, we'll be looking at converting decimal to binary and converting binary to decimal for this lesson. In the next lesson, we are going to look at how we convert octal and hexadecimal and other number systems to each other. So now, to convert from binary, it involves the continuous division of the decimal with 2 and write down the remainder at the right hand side. So after the division, the remainder are written from bottom to the top. For example, here, we are going to convert the number 22, which is in base 10, from decimal to binary, because all decimal numbers are in base 10. So in most cases, you will see situations whereby they write numbers with a subscript under it. For example, if I write number like 56 and I put 10 under it, I'm saying this number is a decimal, is in base 10. And if I'm not even putting anything, it shows that it's in base 10. But if it is in base 8, if I should put 8 under it as a subscript, I'm referring that this particular number is octal. So that is what that stands for, as putting this 22 here. So to do that, say we are going to divide it by 2 and write down the remainder. So we have 22 here. What do we do under the solution? We divide 22 by 2. By dividing 22 by 2, it goes 11 times. And here we don't have any remainder, so our remainder is 0. So again, we divide by 2 again. So 2 in 11, we are going to have 5. And we have a remainder of 1. Then we divide by 2 again continuously. So when we divide by 2 here, we are going to have 2. Then we have a remainder of 1. So we divide by 2 again. 2 inside 2, then we have 1. Remainder what? Remainder 0. So now we are now going to write, after the division, the remainder are written from bottom to the top. So think an arrow from the bottom to the top. The last number we have at the top is 0, 1, 1, 0. So for we can say 22 in base 10 equals to 0, 1, 1, 0 in base 2, which means we have converted this to binary. I hope you understand. So that's how that one goes. Then in binary to decimal, we convert 10110 base 2 to decimal. To convert that, we are going to first write down these binary numbers, the digits. Write them down then we raise them to the power of 0 to the right. So here we have 0, 1, 2, 3, 4. So we do that from the right to the left. Then after that we multiply them by the base. So how do we do that? The first one we have here is 1. So that will be 1 times 2 raised to power 4. Yes, plus, put that into bracket. Then 0 times 2 raised to power 3 plus, then we have 1 times 2 raised to power 2 plus, then we have 1 times 2 again raised to power 1, then plus 0 times 2 raised to power 0. So after that, the next thing we do is that then we multiply this. 2 raised to power 4 is 2 times 2, which is 8, times 2. 2 times 2, which is 4, times 2, which is 8, times 2 again, which is 16. So we have 16 here. 16 times 1 is 16. Plus, then we have 2 raised to power 3. That is 2 times 2, which is 4, times 2, which is 8. 4 times 2 will be 8, times 0. Anything times 0 is 1. So we have 1 plus, then we have 2 raised to power 2 here, which is 2 times 2. That is for 4 times 1, it's going to give us 4. Then at the other side here, we have 2 raised to power 1, it's the same thing as 2, multiplied by 1 is 2. So plus 2. Anything raised to power 0 is 1 times 0. Then we have 0 plus 0. So we're going to add them together by adding 16 times 4. No, this should be 0. 2 raised to power 3, that is 8 times 0. Anything times 0 is 0. That should be 0. So we have 16 plus 0, which is 16, plus 4, which is 20, then plus 2, which is 22. Then our answer is 22 base 10. So that is how we convert from binary to decimal. Then we have an assignment here that you should go and check out. Then in the assignment you are going to convert the binary number 11000101 to base 10. And we're going to convert 253 base 10 to base 2. So this one means we are converting it to decimal. We are converting from binary to decimal. And this we are converting for decimal.